All right, so we're going to get into 4 examples on how we can go about calculating for molarity or calculating using molarity. So this first example, how many moles of barium sulfide would be used to make 1.5 times 10 to the third milliliters of a 10.0 molar solution? Sorry for my handwriting, everybody. It's not exactly the best, but I make do. So, molarity, let's think about that for a second. Molarity is equal to moles of solute divided by liters of solution. So, do I have moles of solute in my givens? How many moles? Blah, 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 blah. Nope, I have a question that says how many moles. Okay, so that's an unknown. Let's look for the liters of solution. Do we have liters of solution? Well, no. But wait, I have a different volume. I have milliliters. Okay, so I'm given 1.5 times 10 to the third. It's a 3 milliliters. Okay, so I can get somewhere with this information. What else do I know? Oh, molarity. I know the molarity. It's 10.0 molar. Okay, so molarity, check. Volume of solution in liters, well, kind of, sort of check. Okay, so we're left with moles that we've got to find. So, let's get this given in volume into liters instead of milliliters. So let's go ahead and convert that first. 1.5 times 10 to the third milliliters. But I don't want milliliters, I want liters. So 1,000 milliliters are in every 1 liter. So that means that I'm going to take 1.5 times 10 to the third, or 1,500, and divide that by 1,000, which gives me 1,500. Nope. 1,500 divided by 1,000 gives me 1.5. So 1.5 liters. Now I have my liters of solution. I can plug everything in and solve, right? Okay, so let's do that. 10.0 molar equals, what goes on top? We don't know. Okay, so we'll call that X. What goes on the bottom? 1.5. Okay, 1.5 liters. So how do I solve for X? I can multiply both sides by liters, right? Okay, so that's multiplying by 1.5 liters. Okay, now my 1.5 liters canceled. Let's think to our unit that's here. So we have 1.5 liters, that's liters, times 10.0 molar. Molarity is moles per liter. And that's all equal to X. So if I look at that, my liters cancel, don't they? So I am going to leave I'm going to end up in moles. 1.5 times 10, X is equal to 15 moles. 15 moles of what? 15 moles of barium sulfide. There we go. That's how many moles of barium sulfide would be used to make that solution. Our next example, number 2 of our molarity examples, says calculate the molarity of a 275 milliliter solution containing 15.7 grams of calcium carbonate. So this one needs to get out of milliliters and to get out of grams. So I am going to have my molar mass at some point here because it says I want molarity. So let's go to our equation. Molarity is equal to moles of solute over liters of solution. I have milliliters of solution. I have grams of solute. And I do not have molarity. Molarity, excuse me. So I am going to take my 15.7 grams and get that in the form of moles. So I need molar mass. My molar mass of calcium is 40.08 grams per mole. So to find molar mass, I'm going to take calcium, carbon, and 3 oxygens and add them up. So calcium, 40.08 grams per mole. Carbon, 12 grams per mole. And 3 oxygens, 48 grams per mole. Remember, these all come from the periodic table. So this is going to come out to 100.08 grams per mole. Now that I have this information, I can use it in my equation. So molarity is equal to 100. Nope, that's not it. We need not this. We need to get out of grams and into moles. That's all that we need here for that. Why in the world would we go ahead and put the molar mass up here? We don't want the molar mass. We're given a given up here for a reason. 15.7 grams of calcium carbonate. So let's think back a second. Break it down a little bit. Let's work on it. So our given 15.7 grams of CaCO3. We just calculated molar mass so that we can get out of grams and into moles. So 100.08 grams on the bottom, 1 mole on top. Set that up. That's calcium carbonate. We always write our substance. So 15.7 divided by 100.08. Gives me 0.1569 moles of CaCO3. So now I'm going to take that information and divide by the volume. So big M, molarity, I can't talk, I'm sorry, molarity equals moles, 0.1569 moles CaCO3 divided by my liters of solution. Well, I don't have liters, I have milliliters. But that just means I'm dividing milliliters by 1,000 to get liters. So 275 over 1,000 means that my decimal point is in front of the 2. So 0.275 liters. So 0.275 liters of solution. Then I just do my calculation. That comes out to about a little more than half, 0.570 molar. That's the concentration of calcium carbonate in solution. Our next example is going to be this one. What is the volume of a 3.00 molar solution made with 122 grams of lithium fluoride? So take a moment and think about how you would go about trying to solve this, and then we'll go through it together. Okay, so just a few more moments to think. Think you have it? All right, let's see. So let's pull out what we're given, what we need. Question says, what is the volume? It gives us molarity and it gives us grams. we're dealing with molarity. We remember molarity is equal to moles of solute over liters of solution. Okay, so we've got molarity, check. We've got mass of solute, kind of check, almost check, okay. And then we want the volume of the solution. So, step one, we need to get out of grams and into moles. To do that, I need molar mass. Lithium molar mass, excuse me, there we go. Molar mass of lithium is 6.941 grams per mole. And of fluorine is 18.998 grams per mole. So I'm going to add these two together because I only have one lithium, one fluorine. So that's 9, and 8 plus 6 is 14, 15. Okay, so we got 25.939 grams per mole of LiF. So I'm going to use that. We learned our lesson in the last one. We're going to take our given 122 grams and solve for moles. So 122 grams LiF, 1 mole on top of LiF, on the bottom 25.939 grams of lithium fluoride. So when we do that, we get 122 divided by 25.939. We get 4.7033 moles of LiF. Then my next step is to divide by volume, but I don't have the volume. I need the volume. So if I go back to my problem, it gives me molarity. It gives me, now I have moles, I don't have volume. So let's set it up. 3.00 molar is what it gives me, is equal to 4.7033 moles divided by, we're going to call it X. So we got to get X by itself. To do that, I'm going to multiply both sides by X. Now I've got 3.00 mole per liter equal to, X times 3.00 moles per liter equal to 4.7033 moles. Now I need this guy to go away from the left side. So I'm going to divide both sides by 3.00 moles per liter. That's what molarity is. Okay, so my moles cancel out, and I've got liters on the denominator of a denominator. That means that the liters are actually on the numerator. So my 3.00 cancels out on the left side. X is going to equal to a certain number of liters. So we take our 4.7033 divided by 3.00, and that gives me 1.57 liters. 1.57 liters of solution. Okay, let's look at the last example, number 4. And number 4 says how much calcium chloride, CaCl2, in grams is needed to make 2.0 liters of a 3.5 molar solution. So we want to know grams of CaCl2. We know we have 3.5 molar solution. we know we have 2.0 liters. We don't know moles. The moles will need to be in CaCl2. Okay, so let's find our moles first, and then we can take our moles to grams. So 3.5 molar is equal to our unknown X divided by 2.0 liters. Now what I'm going to do is I'm going to replace this molar with what it's representing. It represents moles per liter. So I'm going to put that instead of the big M here, mole over liter. The reason I'm doing that is to show what I'm canceling and what I'm not canceling. So I'm going to multiply both sides by 2.0 liters, canceling out the 2.0 liters. Okay, so I've got 2.0 times 3.5. 3.5 times 2 should give us, hopefully you're saying it, 7, right? Okay, so 7.0, the liters canceled. Moles. And what's it moles of? Well, what's it asking for? Calcium chloride, CaCl2. Now, before we go in ahead and say, yep, that's my final answer, done, look back at your question and make sure that's really what it wants. Did it say it wants the number of moles of calcium chloride? No. It said to find the number of grams of calcium chloride. I can do that if I have moles, though. So I'm going to take this information and go from 1 mole of calcium chloride on the bottom, and it's for a number of grams of CaCl2 on top. I need that information. So I need the molar mass. Calcium's molar mass is 40.08 grams per mole. Chlorine is 35.45 grams per mole, but I have 2 of them. So 2 times 35.45 gives me 70.9 grams per mole. Add those 2 values together. 7 plus 4 gives me 11, so 110.98 grams per mole. So that's going to go up here, 110.98. Now what? Oh yeah, I just multiply, right? Okay, so 7 times 110.98. That's a lot of grams. Equals up here, sorry. 776.86 grams. But let's say that we're talking about significant figures. The smaller number of significant figures is what we're answering to in our problem. Both of those givens are 2 significant figures. So my answer will be to 2 significant figures, which means I'm going to have to round. So I can either write this as 780 grams, or I can write it as 7.8 times 10 to the second grams of CaCl2. And there we have it, your 4 examples.